Hello, this is Seon Wang from Knowledge Based Design Laboratory. I had originally planned to go on my personal project of building a machine learning based search engine, but I had to switch to the class project. Here are the things I've done so far. Um, I started with the analysis on the Street Fighter 3. I found a bunch of JavaScript files that renders image binary. That image binary is rendered to our screen and captured by Python environment file given to us. And with this image binary, we are given with additional information of lateral position and health of each player. But I thought more information should be fed to the AI, and my question was that how are we gonna abstract the image meanwhile losing that much information from that image binary in real-time basis? The image binary was too big, in my opinion, to feed into any kind of artificial intelligence being. So I felt some kind of abstraction is necessary before learning or competition. I found these library of files in the browser console, and particularly images inside these folders were just cropped and overlaid to make the game screen a game screen. This is one of the example from that folder. We can see an array of fire effects, and there were so many of them, including the status of each player here. So I thought, why can't I just utilize this to pre-process the image? That would make things even simpler. First thing I searched for is the best way to detect something from bigger images so that I can basically know what other player is doing. That is called image template matching, and that function happened to be supported by OpenCV. I tried first to run their Hello World script for image template matching. In this script, the face of Messi here is tried to be matched in this picture here. They provide 6 methods like so, and here are the results. They're very fast and good in my opinion. It took something of an order of 0.1 seconds for each template to be matched in bigger image. So that is very promising for me. And in the next section, I started with working with JSON here and parse this image into each section. Here are the loaded JSON from Street Fighter 3, and I made another JSON so containing what to do with each image. This instance of image is divided to 15 sections. You can see here 15 array of fires, and I decided to focus only on the red channel, and here are the results. These were originally one laterally long array of fire images, but I sliced them up to each one of these. This is how I pre-process the image so far. I think there are many advantages to heavier image processing than commencing on the machine learning soon. They are accurate representation of game state and faster learning rate and frame rate that would aid me in the competition. Um, so how are we gonna make the game? This is the architecture of the artificial intelligence I'm gonna build over the course of this week. They're basically based on Dockers, and the most important would be this Selenium Docker on which the game runs. Um, this Docker renders the graphic and sends the game graphics to template matched Dockers. These Dockers will basically do this, and there can be multiple instances of these Dockers depending on the pace of the game that will be played on the competition environment. This Docker sends the game state it figured out to reinforcement learning Docker, and this Docker will decide which action to take